Welcome to the next video in my series on essential skill number 1 for AP Chemistry, dimensional analysis and mole conversions. So in this video, I'm going to cover sort of a type of mole conversion problem related to the energy of light. So this equation that we have to calculate energy, this is for the energy of one photon, okay, or one particle of light. Sometimes though, energies will be given to us per mole, as in this problem. They give us the first ionization energy of potassium in kilojoules per mole. Okay, so what we're going to have to end up doing, we're trying to calculate the wavelength, the maximum possible wavelength. So wavelength is this symbol here. So we can kind of combine these equations because they both have this V looking symbol, which is the frequency. So what we can do is we can take this equation and say frequency equals energy over h, which is Planck's constant, and then replace that here. C equals lambda E over h, and then rearrange that to solve for lambda. So we get speed of light times Planck's constant over energy. So that's the equation that we're going to ultimately end up using, okay? And we do see that wavelength is inversely proportional to energy, okay? So that's why it says maximum possible wavelength, because we need a minimum amount of energy. We need at least this much energy, but we don't want it per mole, okay? And so that minimum amount of energy will correspond to a maximum possible wavelength. But again, this needs to be the energy of one photon, not the energy per mole. Okay, and it also needs to be in joules because Planck's constant is in terms of joules. So what we're going to do is we want to find the energy of one photon. So I'm going to do a sort of dimensional analysis / mole conversion. So I'm going to start by actually just saying one photon. I have one photon, or I'm interested in the energy of one photon. And then I am going to convert that to moles. So in 1 mole, there are Avogadro's number, 6.022 times 10 to the 23rd photons. Because remember, a mole is this number of particles, and it can really be any type of particle. Normally we're talking about like atoms or molecules, but photons are a type of particle as well, a particle of light. And then, so your photons will cancel. And then now that we're in moles, we can multiply by the kilojoules per mole. 419 kilojoules per 1 mole. Moles cancel. And then, like I said, we want our energy to be in joules as well. So we'll convert kilojoules to joules. There's 1,000 joules in 1 kilojoule. And so we get that one photon of this energy has 6.96 times 10 to the negative 19th joules of energy. And then we can just simply plug everything in to that equation that we derived. So C 2.998 times 10 to the 8th meters per second, H 6.626 times 10 to the negative 34th joules times seconds over 6.96 times 10 to the negative 19th joules. And we get 2.86 times 10 to the negative 7th. If we look at these units here, well, these joules will cancel. And then these seconds will cancel because this is per second, this is times seconds. So those will cancel, and then you're just left with meters. Meters, which is a sensible unit of length, wavelength. Okay. Now it does ask for the possible wavelength in nanometers. So the conversion is that there are 10 to the 9th nanometers in 1 meter. So we will do 2.86 times 10 to the negative 7th meters times meters on the bottom, nanometers on top, 10 to the 9th over 1. And so 10 to the negative 7th times 10 to the 9th, that's going to be 10 to the positive 2nd. You add the exponents. Okay, or if we write that as a regular number, 286 nanometers. But the main thing I want to illustrate with this example is just in tying into the rest of this sort of essential skill unit is this dimensional analysis conversion and seeing how just another application of how it can tie into other equations in chemistry. This is going to be a common theme in the future videos. It is how, you know, we may do a dimensional analysis mole conversion, but kind of having its own unique tie-in to a different topic in AP chemistry.